Okay, so today we got a couple more vocab words I want to cover today, but got a little more hands-on today. Since geometry is a lot of sketching and looking at drawings, today we're going to get to a couple constructions today, at least one or two I'm hoping, that we can get a feel for what we're going to be doing throughout the year. There are certain types of constructions. I think there's like 17 constructions we learned. So if you've taken drafting before in shop, if you've had the luxury of doing that, you're going to be pretty good at this. But this is an easy one today. I want to start us off nice and easy. It's a little hands-on, you get some drawing, you get some points for doing it. I know that seems odd, but it's one of those things like we need to practice it, so you do get rewarded for it. So we're going to do that today. That'll be one of the last things we do today. But let's get to some of the vocab. So the vocab that I want to start with today is, let's start with the word space. There's a word that I used yesterday. Where you've seen this word before, it was when we talked about the word point, right? It was a location in space labeled with a capital letter. I never defined what space was. Okay? Anyone venture guess? What do they refer to as space? What do you think? What would space be? Where would a location in space be found? How would you describe it to somebody? Yeah, I'll take that. What do we think? It's the easiest way we can describe space. Not the final frontier, if you ever watched Star Trek. Space and geometry. Is it two-dimensional or three-dimensional?
Three-dimensional.
Three-dimensional. Okay. It's a boundless, three-dimensional set of all points. Those are the two major bullets. It's boundless and three-dimensional, and it's the set of all points. That's how the book described it. In almost every geometry textbook I've ever taught out of for the past 14, 15 years, they always say the set of all points. That's what they say. In every textbook. And I've had a lot of different geometry books. So, set of all points. So it can be anywhere. That's why I like that first activity we did, that little brain teaser, that challenge question. You had to think outside the box, where the point was off the marker board from the fountain and the tree and the flagpole. All right, so that's space. So the set of all points can be in there. This room has space. It's three-dimensional. It has volume to it, right? A length, width, and a depth to the room. Well, the points that you put on your paper, so if you've been drawing pictures, or the pictures I draw on the marker board, they're defining space. Now, to define an actual three-dimensional, not four-dimensional, but three-dimensional room, you need at least 4 non-coplanar parts. So, this is the idea. I'm going to put this on here. You need 4 non-coplanar points. I'll let you write that down. There's a new vocab word in there that's going to lead us into it. Four non-coplanar points, and that leads us directly into that next word, which is coplanar. That's one of the words we have to talk about. So you have 4 points. Well, we have to have non-coplanar. Can somebody guess what coplanar means? Coplanar. What do you think? Co meaning grouping or two or more. Planar, what does that word mean? Please.
Points in the same plane.
Nailed it, right? Coplanar, points contained on the same plane. Points contained, that means to be on. Contained in the same plane. That's coplanar. I want, on this particular definition, non-coplanar. 4 of them. So coplanar means in the same plane, non-coplanar means not in the same plane, right? Now, why does it have to be 4? It seems like an odd number, right? It's not odd, it's actually even, but you get the idea. It's like, why would they pick 4 randomly? Why would they have to pick 4 points to define like volume, the size of a room? Please.
For each side, maybe.
Okay, close. You're almost on it. You're almost on it. Anyone else have a guess? I'm gonna come back to this. Okay, let's get back to this idea of like defining the corners of the room, right? Well, the idea is that if you're going to define the walls in this room, having 3 dots, like top left corner, top right corner of the room, the bottom of the room, so that way you define the wall that you're looking at in front of you. The wall is like a plane. So when you have 3 points that are non-collinear, that defines one plane. By picking a 4th, that defines how deep of the room you can go. And you're almost right, it's defining the space of the room, where the corners are. So by picking 3 on one wall, like this wall right here, and then picking a dot that's off of the marker board, like out here, now you have a 3-dimensional space you can go to. So that's the idea, that's why there has to be 4. 3 of them will define a single plane, but the 4th one will define how deep it goes in the room. That's the idea. You can't just pick all 4 on one wall. It just defines the plane of the wall itself. So yeah, so that's the idea. It has to be non-coplanar, at least 4. So really 3 of them are always on a plane, but the 4th one wouldn't be. And that would give you the depth to the ring. Okay, now, before we move on, is there any particular question you have about these 2 words? I kind of really threw you in the deep end with those 2. Okay, so coplanar, non-coplanar, space, that type of thing. All right, let's get to the next word. So we've talked about collinear. Collinear means on the same line, right? So I'm just going to put that up here. That was one of the words. I don't know if I've actually officially wrote the definition up here. I think we've just discussed it, right? Collinear means points on the same line, points contained on the same line. Bless you.
Thank you.
Points contained on the same line. So these other ones go down. Just barely hear that. All right. Okay, let's get to another word. So we had collinear. All right, so now we need to talk about those 3 types of interactions. There's 3 types of interactions that lines, planes, other things can have. Now I'm gonna define this to lines only, and then we'll talk about planes here in a minute. What can planes do? How do they interact with each other? What could happen, please?
Parallel.
They could be parallel. Nailed it. There's one. We talked about that. Parallel is like the railroad track, right? They don't need to touch, but they're somewhat related. Another one.
Could be skew.
They could be skew. That's huge. So skew lines would be on different planes, right? You could have a line coming out at you from the marker board, and you could have one over here on the marker board, and they're going 2 different directions. They're not touching, it's not parallel, but they're going different directions because they're on different planes. So that's good. There's another one. What's the other type of interaction lines could do? They're not parallel, they're not skew. What else would happen? What if they were to touch? What would that be called? Intersection. Yeah. That's the 3rd type. So there's an intersection. Now, intersection they can touch. There's a different word, and I'm surprised your book never discusses it. An intersection is where they share a common point. It's any geometric object that shares common points, right? So like 2 lines could cross, right? And they would share a common point. It's 2 geometric objects, they meet at a single location, a point. You could have planes that cross, right? So the best way I think of it is like hold out your hand. I know this is like a visual aid, it's dumb, but you'll get it. So you hold out your hand. So imagine that's a piece of bread or a piece of paper. That's a plane, right? It's a flat piece of paper in front of you. And then you have a butter knife or a scissor that you're gonna score the bread or the piece of paper, whatever you're cutting, Well, when you have a blade and a piece of bread and you score it, what happens to the bread? It's cut, right? And you have a line that perfectly shows up. You can actually see that. So imagine that my marker board here was a plane, this one, and this marker board is a different plane. It's like the bread or piece of paper. When they meet, they make a line. Two planes, when they cross, make lines. You can see it in every corner of the room, even the ceiling meeting. They make lines when you have planes crossing. When you have lines that cross, they make points. So now you're going to see, I want to break your brain just a little bit. So to make a single point, a single dot, you need lines crossing. Okay, got that? The two lines cross, makes a single point, a singularity. But what makes a line in the first place? How many dots need to be on a line? Two. Well, to make a second one, you'd have to have another line crossing. Because you need two dots. And to make a dot, you need two lines crossing. Well, this line also needs another one. And this one would need another one. And so now you're starting to see like there's a web that are starting to form here. And to make the lines in the first place, you need planes crossing. A plane going this way, a plane going this way, and they'll start to make lines crossing. So everything is connected. Planes make lines, lines make points, and it goes in this big circle. It's the weirdest thing when you start to think about it. It's like one object needs the other one to make it in the first place. It's the hardest concept to wrap your head around. You can't just have them single. They make each other. So they work together. Now, coming back full circle to this question, it's like there's another word the book never described. Lines could touch. They could cross. Planes could cross. They could intersect. They could share points. What if they shared every point? Everything, not just one. Not just like two lines crossing, they share one point. What if they were right on top of each other and they shared everything? Two of the same lines. And the book ignores this, but that's called to coincide. To coincide is to share every point, not just one, or just a select few. A select few points that meet a certain stipulation is called a locus. A locus is a set of points that work, right? The book ignores that. I believe there should be a fourth type of interaction. You could have two lines right on top of each other. To prove my point, maybe you've experienced this before. You're writing in your notebook, right? You're writing your notes, and you turn your page, and you go to the back, and you start writing notes. Has anyone ever experienced this? Like you go back to the first page to look at your notes, and somehow the lead or the graphite, I should say it's not lead anymore, it's graphite. How many people have noticed the graphite from the piece of paper has copied itself onto the paper in front of it because you're running your hand on it? Your papers were literally coinciding and sharing everything, including the graphite. They became one, and it's a perfect mirror copy of it. That's why when you have a checkbook, right? You guys will probably never have to deal with checks. But if you had a checkbook, right? You have a check, you write your little signatures, blah, 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 you put your money in there, okay. What most people should do, they don't think about this, every time you're gonna write a check, you should tear it out first. They always have a perforated edge. Tear it out first. Put it on the counter and write on the counter. Because if you write right here in your checkbook and then you tear it out, your signature has buried itself on all the papers down below it. So if somebody were to steal your checkbook, they have your signature. Because it's like the situation with your notes. You turn the page, you started writing on the back, it shows up. Just to prove the point, if you had a checkbook and it was blank like you've been using it, you could take a pencil and start to like shade in right where the signature is, and you'll see where your signature was, and you'll see exactly what it is. So now somebody has your signature. It's a common way of identity theft. But it's one of those things like, it comes back to this, right? Simple geometry concept. If they coincide, they share everything. Down from the beginning. A lot of people don't think about that. I think it's a fourth interaction. When they share everything, not just one object or a locus of objects. Okay, enough spitting out just random things. All right, Let's move on to the next part. So there was something I talked about the other day, and I want to get to it today. It was the types of lines that we had. I want to get to those today. So we talked about space, talked about points, lines, planes, obviously some of these new vocab words, but I want to talk about the types of lines. How many are there? What do you guys remember me saying?
3.
3. There's 3 types. 3 types. I want to get to them today. Give you a definition, show you what they look like, how would you answer a question. Now the good news is the homework I assigned yesterday, so if you were gone or absent yesterday, we had an assignment, page 8, that's due on Monday. So if you want, go back and watch the video. I believe the video is working as recording this morning. It took a little bit longer uploading last night because I recorded the volleyball game and I was uploading the volleyball game last night for Huddle, for the volleyball team. So it's on there. It's just, it might have taken a lot longer than it usually did. Okay, so 3 types of lines. First one is self-entitled. They just call it a line. Okay, that was one we've already had. That was the one that was in your homework, right? So line, what it looks like this, right? It's got arrows, it's got, points on there, a minimum of 2, like that. They could have a cursive letter or italicized letter off to the side. How would I name that line? Please.
A, B with lines over the top, or
Yeah.
line L.
Good. You have the arrows. You could have line L where you actually write the word line and you put the little L after it. Perfect. Is there another name you could call it? Say BA. I just switch the letters around. Yeah, they mean the same thing to me, but you have to have the arrows. Don't mix and match the 3 together. Like don't put the word line in front of 2-letter system. If you're gonna use the cursive letter, that's when you can use the word line. If they have any more dots on the line itself, just pick any 2. I don't care. Maybe it's C and A and B. Just pick 2 letters. So CB, I don't care. Or CA or AC, whatever you want to pick. Just 2 letters only. Do we feel comfortable with the first type? 2 points, the distance between them, and extended in both directions without limit. I believe that's the definition we used. Now, let's get to the second type. I'm going to put it over here. All right, second type. And these are in no particular order, by the way. It's called a line segment. A line segment. Anyone happen to know what a line segment would look like? Please.
Isn't it just a line between 2 points, but it doesn't extend?
Exactly. Nailed it, right? It's the distance between 2 points, and that's it. It does not extend both directions. That was the best way you could put it, right? So the distance between 2 points, that's it. So that's a line segment. It contains 2 endpoints. So the distance between 2 points, those points are called endpoints. They end. It stops. This is measurable. You could put a ruler down and measure how long it is. Like if you looked at the board and went, let's say that's 7, 8 inches, maybe 10 inches. You can measure it. As opposed to this one's infinite. I'm not even going to put a ruler down. Now I could measure the distance between points like A to C or A to B, but that would just be a segment. If I had to measure the whole thing, there's no point. It goes forever. That one doesn't. Now, how do you think we name it? Like, how would you write down the notation? How would you answer a question and said, hey, name the segment that's exactly 8 inches long on the marker board? How do you name it? Please.
Maybe you write segment DE or...
Okay, that's how you say it. You're absolutely right. That's how you pronounce it out loud. You say segment DE or segment ED. But how would you write it? How would the look? Because you said it right. You wouldn't have to write the word segment though.
Not with the arrows?
Not put the arrows. Easiest way to do it. DE, and just not put the arrows on it, put a little bar above it. Now, the bar above it just means the physical drawing of it. If you leave the bars off of it, because you can do this on a segment, you could leave the bar off the top. Now, if you do that, you're talking about the actual raw distance of it. You're talking about the actual distance. So this would be 8 inches. Do we see the difference? D with the bar means the actual physical drawing. Leaving the bar off means the actual 8 inches. The book, for some reason, doesn't distinguish the two. They just mix and match them all the time. There's a purpose to it. Leaving the bar off means the raw distance, you measured it. Leaving the bar on means the physical drawing of it. So be careful. All right, questions on that? Now, on segments, just before you get another question, I'll give you a little more time to think of one. They're not going to use the italicized letters. They're not going to do that. Sorry, that's only really for lines. But any other questions you guys may have? Okay, let's get to the third type today. Third type, then we'll get to some drawing. Third type, and this is the one I'm kind of worried about. It's the one that most people mess up, because there's, like, those are easy, right? You write the 2 letters, put a bar or some arrows, fine it. The last one is the tricky one. The third type is called array. Array. It's kind of like mixing the previous 2 together, a segment and a line. There's a weird mix. So, it is a line that is extended in one direction. Extended in one direction without limit. And an endpoint on the other. Sorry, my penmanship is terrible today. A line extending in one direction without limit and an endpoint on the other. To me, it looks like an arrow, like a traditional arrow you'd see if you were drawing one on a piece of paper. Endpoint, arrow. It can point in any direction. If you're in physics or a science course, this really looks like a vector. A vector has magnitude and direction. But the idea is that we don't measure this. It's non-measurable. It's very different than a vector from physics class. So what letter did I leave off with? F. So F, that's a terrible black. What's going on here? We have an F, and then maybe down the road we have a G. So now, when we name it, this is the part a lot of people get wrong. Okay? You can put the letters down. Question?
No.
Oh, okay. You want to say it?
Yeah.
Okay, please.
Is it FG with the line on top and an arrow pointing towards the G?
Yes. Okay, this is how I want to see it, right? It's common sense. Like, you're thinking, well, that ain't hard. Like, how would people mess that up? But just like the others, just like the line segment, just like the line, you can switch the letters around, right? Because it doesn't matter that it's not alphabetical. So you can just switch the letters around. Now, then, like you were saying, which way does the arrow have to face? Repeat that again.
Towards the G.
Towards the G. This is the part that people get wrong. Because I don't care the letters you write, but you have to have the arrow facing the letter it's passing through. It's how I think of it. It's like the endpoint has to be above the correct letter. So if your endpoint's F, it better have the endpoint above it, right? The arrow's going towards the other letter. Even if there's more letters down the road, I don't care. Pick one. So if I had H, FH, fine. The arrow's going towards H though, because F was the endpoint. And yes, you have to use the endpoint. Just saying, you can't mix and match. Okay, was there a question now? Or do you have an idea what you're going to do? Okay. All right, I don't know why. People mess that up all the time on my tests. They just butcher that one. This one. for some reason, I get to the test, I get to a certain question on the test, and it's like question number 8 or something, and it just goes downhill super quick, because they forget about this. They forget which way the arrow has to face. It doesn't have to look like the picture, it has to point towards the right letter where the end point is, right? So don't think that, oh, the arrow has to point this way because that's what the picture looks like. It doesn't matter. My arrow's going down, not side to side. Okay, questions with all that? Okay, let's get to our drawing today. So you can put everything down below you. Everything down below you. All right, I'll put my little mask on so I can walk around. All right.
So we need our notes anymore.
No, you won't need to. No, this will be the last thing we're doing today. Okay, I'm gonna hand you a piece of paper. You can put your name on it. You can even put what period you are. That's really all I need to see, because we're gonna do a little bit of a drawing. I know this is silly and stupid, but I think it's important that we get to see it. This is the first construction of the year, so if you've taken drafting before, for shop or fabrication courses, this will seem super simple and kind of almost silly, but they get more complicated as we go. And we will turn this in, so don't start drawing weird random stuff on there. I don't like to look at that.
Is there names on it?
Yeah, name, period on it. Okay, now I'm going to hand out some tools here. It's called a compass and a straight edge. It's a little piece of plastic. If your compass, the metal geometrical compass, doesn't have any lead, let me know, I'll get you another one. I have like 25 of them here. So, all right.
Well, I have one of these.
Oh, well good, you could bring it. That'd be a helpful thing. Yeah, in this course, we'll start to learn how to use these tools properly, because that is one of the standards we need to learn, is how to use the tools in mathematics correctly, accurately. It's one of the standards of mathematics we have to learn. Now, check out your compass, take it out of the little package. There might even be like a little pouch in there that has lead in it. Some of them have. They're like, I think they're 1 year old. I just got them last year. I paid a fortune for these things. They're mine. I bought them all. Okay, does everyone have lead? If it doesn't even have to be sharp. I mean, it could be like almost non-existent. It just has to be there. If you don't have lead, let me know. Now, how you open it.
Dial in the center.
Yeah, that gear, that lever in the center, you just gotta spin it. You don't pull the arms apart. So, question?
Yes, I have some of these at home, but they don't have the dial. Is that okay?
Yeah, that's fine. Same thing. Yep. All right, so this is kind of what it looks like, right? You got one side has a pipe. Don't poke yourself with that. It'll give you tetanus pretty quick. It's metal. Don't do that. And then on the other side, it's got a little piece of lead or graphite. Sorry, I keep saying lead. It's graphite. But a lot of people don't know what it's used for. Like a lot of people when they're handling one of these things, their urge is just, oh, I'm gonna draw circles all day long, and that's the purpose of this thing. And it's not even to draw like really dark, because some people want to draw super dark and they just grind that graphite right into the paper and then it's gone, right? It's when you're drawing with a compass, when you make your first couple sketches, your neighbor next to you shouldn't be able to see it when you're drawing. It should be super light. Then what you do is you go back later and you take your pencil and you darken it in. Does that make sense? So that way you're not wasting the light. It's not like me personally, that's how you're actually supposed to do it. Because if you put pressure on this thing, what happens is that it moves on you. And it's not the compass fault. These are really nice compasses. This is my really weird looking compass. This one with the marker, right? So you got your compass, right? If you're gonna push really hard, what's gonna happen? It's gonna expand. It will do it, right? There is a little give and take to these things. So you gotta be super light. And if you push lightly, like you can hardly see that, there is that arc on the board. My compass never moved. It was super accurate for what I needed. So then I can go back, take my pencil, and then darken it in right where that path went. That's the idea. Okay, enough of talking about this stuff. Let's get to the actual drawing. So above your paper, I'd like you to take the straight edge, that little piece of plastic that you were given. right? It's actually a zip strip.
It looked like
Yeah,
one.
it's super thick zip strips I use for like holding wood together. I cut a bunch of them up, they've never been used, they're brand new. And what I'd like you to do is above your picture, so I'm gonna draw your paper just because you have a little piece of paper, right? Just up here, draw a segment, and let's call it A to B. Choose your little straight edge, draw A to B. It doesn't have to be the full length of your straight edge, just draw any length you want. Don't go too big though. So draw a segment. And again, don't go all the way across the paper, don't use your whole straight edge, just draw a little stick. And you can label, I don't care how big it is, yay big, cool, that big, right? It doesn't have to be huge, just that big. Any size you want, it doesn't have to be particular. Now, here's my question. Did I give you a measuring tool? Did I give you a ruler at any point? No. Like, I don't know how big of a line you just drew. Like mine on the board, no idea how big it is, right? I mean, that looks 4 inches, 5 inches, something like that. No idea. How do I copy it if I don't know how large it is? Is that rain?
Yeah.
Good Lord. Question. Yeah. Yeah, if you need to know how large of a line you have drawn, your compass will do that for you. Now, before I do this, because yeah, you could take a measuring tool, a lot of you have rulers, you could put it up here and go, okay, I'm gonna measure it, you know, it's 3.5 inches, and I'm gonna go down here and draw 3.5 inches. I wanna draw this without measuring it, like exactly. So here's what I want you to do. Below your paper, take your straight edge. I don't know if I have a ruler up here. Imagine I have a straight edge. Let's see, is there one back here? Here's one, I see it. Okay, now, ignoring the fact that mine's a ruler, just imagine this is like a piece of plastic like you guys have, sorry. Okay, so I'm gonna go down on your paper this direction, and I'm just gonna draw a line. I'm gonna make it obviously longer than the AB one that you just drew a little bit ago. I'm gonna make it obviously longer. So draw that right now. Go to the bottom of your paper, draw your segment that's bigger than AB. Go do that right now. I totally broke this one. So you're drawing a segment that is longer than AB and it's clearly longer. Okay. Now what I want to do is I want to copy AB to that segment to make it the exact same size. So pick up your compass, and I want you to open it up so it'll touch both endpoints of A to B. I don't care where the pike is or the pencil is, just make sure you open it up and it touches A and B, the endpoints, like this. And you can use that little gear in the center and spin it. Hopefully it'll reach. If you drew your segment too long, yeah, you'll have a problem because you won't be able to reach it. And then you might have to shorten it up and draw a new one. Okay, does everyone have that measured?
Yep.
Give you a few seconds. It's pretty easy. Okay, got it? Okay, so once you have AB measured, you're gonna go down to the new segment using like this endpoint over here, let's call this C, the endpoint on the left side, let's say.
Left side.
And then left. And then what you're gonna do is you're gonna make a little hash mark over here. Oh my gosh, I can't even see it. My marker died. Oh, it's right there. Okay, does that make sense? You're just making a little hash mark. Don't make it dark. Just, you know, you're putting your compass, you know, you just measured AB, you picked it up. I'm not changing the compass at all. I went down to my new drawing and made my little hash mark. Don't erase anything. In geometry class, we never erase. What we do is you just pick up your pencil and you scribble out the excess you don't need. You scribble it out. It's not important. We don't erase anything here. I want to see every marking you can have. Now, if we call this point right where that point of intersection was, we call that D. What can you tell me about these two segments?
They're the same length.
They better be exactly the same. In fact, this tool you're using in front of you is far more accurate than any ruler you'll ever use. The reason why this is far more accurate than a ruler, you're like, Lord, I can measure it. A ruler, there's gaps between the hash marks that you can't account for. Because maybe my marks were directly between the hash marks, and you want to be exact. This is far more exact than any ruler will ever be. So if you're going into architecture or some type of drafting, or you're going to be in design, this tool, these two tools, I can draw anything with these two tools. I can draw perfect boxes, perfect 30, 60-degree angles, 90-degree angles with the tools you have in front of you and nothing else. It's wild what you can do with these things. I can draw circles and cut them perfectly in half and then have angles coming off of them and perfect lines that just hit the circle perfectly once. It's crazy the level of detail you can get with just the two simple tools. I'd like you to put your tools back in the baggie. Make sure your paper has your name and period on there. I'm going to collect those here in a second. I know that seems silly. This is a first construction. It's the easiest one possible. All we did was copy a segment from one part of your paper to another, and we never used a ruler to do it. And it was the exact same size. So if you're in drafting or in architecture, you can make a room with all the walls being exactly the same, with just using these tools and doing the exact same thing we just did. Make sense?
Yes.
Okay, all right. I'm gonna collect my little bag of tools here, and then we'll turn in our little piece of paper to get some points today. Now it seems silly, but we're gonna do a lot of these constructions throughout the year because I think it's kind of entertaining and gives you a chance to relax. You don't have to sit there and worry about math for a while. You can draw. Just make sure your full name's on that little piece of paper. First, last name.
Did I tell you that I go by Cody? Did I tell you that I go by Cody?
Oh, you did not?
I just figured I'd tell you that.
Yeah, good to know.
My paper.
Okay, I'm gonna walk around and collect your paper now. So make sure your name's on it, full name, first, last, all that good stuff. Easy points today. You already got two things that will be in the grade book this weekend. You'll have this and your book.
Have your attention, please. In the west parking lot, in the front row, there's a vehicle